So in this video, we are going to solve a system of linear equations by using the graphing strategy. And remember, when we're solving a system of equations, what we are ultimately trying to find for those two equations is their point of intersection. So we'll be using a graph to help us find that key point for our system. So when we solve systems of equations graphically, we're going to follow three key steps. First, remember that the solution to our system is the one single point where these two lines cross. That's what we are ultimately trying to find. So if we're using the graphing strategy, we are going to start by creating a visual representation of each line. So essentially we're going to graph both equations using what we know about graphing equations. Then, once we have both of them graphed on the same coordinate plane, we're going to determine the point of intersection for those two equations. And remember, our answer should be an ordered pair because our answer is a coordinate point on the coordinate plane. And then what we're going to do is we're going to check the coordinate and make sure that it is a solution for both equations. So here in my first example, what I notice is I have two equations. I have one equation here that contains the variables of x and y. And then I have a second equation here that also contains the variables of x and y. So what I'm going to do is I'm going to graph both of these on the same coordinate plane. Now if I reflect on my knowledge of graphing lines, I know that to graph a line, it needs to be written in y equals mx plus b form. So I'm going to start by rewriting both of these equations into y equals mx plus b form where y is alone. So I start by adding x to each side, or 1x. So I then have 2y is equal to negative 10 plus 1x. And then from here, to get y alone, I divide both sides by 2. So I end up with y is equal to negative 5 plus 1/2 x. And then I'm going to graph this on my coordinate plane. Now remember, I can identify key information in this equation that will help me graph. The number in front of my x is my slope, and because this is a positive 1 over a positive 2, I have rise 1, and then go to the right 2 to find additional points. I also know that this negative 5 here represents my y-intercept, or where I cross this y-axis here. So I'm going to go to my graph, go to my y-intercept, and go to negative 5. So 1, 2, 3, 4, negative 5. And then to find more points, I'm going to go up 1, right 2. Up 1, right 2. Up 1, right 2. And then I can apply that same pattern backwards to get a nice graph. Then from here, I'm going to repeat this process with line number 2. So we're going to start by subtracting 1x from each side. So I have 4y is equal to negative 8 plus a negative 1x. Divide both sides by 4. So I find y is equal to negative 2 plus a negative 1 over 4x. And then again, I know that since I'm in slope-intercept form, that negative 2 is my y-intercept point where I cross the y-axis. And this is a slope of down 1 and then to the right 4. So if I go over to my graph, I go to the y-intercept of negative 2, and then I go down 1, right 1, 2, 3, 4. And then I can repeat that same pattern backwards, and then I can connect my points and graph my line. So I start this process by graphing both equations, and then from here I determine my solution by finding the coordinate point where the two lines cross, which I can see right here occurs at the point x is 1, 2, 3, 4, y is negative 3. So this is my solution. This is the one point on my graph where my two equations cross, the one point that they share. Now, I can end by checking my solution and making sure that it works. And I strongly suggest doing this every time to make sure that you have the correct point. So I'm going to take my values for x, where x is 4 and y is negative 3, and I'm going to substitute those into my original equation. So if I check equation 1, I have negative 4 plus 2 times negative 3 is equal to negative 10. So I have negative 4 plus negative 6 equals negative 10, which I can see is true. And then if I check equation 2, I have 4 plus 4 times negative 3 is equal to negative 8. So that's 4 plus negative 12 equals negative 8, or negative 8 equals negative 8. So again, that point both works in both equations, and as a result, it is the solution to our system.